Take for instance the aerodynamics, like a vehicle, like car. We have what is called car destructive test and non-destructive test. There's some tests that whether you like it or not, it must undergo what is called destructive to see if when it crashes, the people in it will die or not. So they design some robot and place it in the car, and they do some destructive tests. They move the car to hit a wall, and impact force is tested on the car to see if the car is going to destroy so much that, or is going to damage to the extent that the passengers are going to die or not. So those are destructive tests. But even that, they do that on simulation first before they can even consider that, because it's a critical situation. Okay, yeah. So like for the shaft aspect of it, it becomes non-destructive. You cannot do a destructive test on the shaft initially. Of course, I can say initially that what they do before simulation came into the system, they did something like that. But simulation has come all the way to reduce or mitigate a lot of cost issues in terms of the time, in terms of the aspect, in terms of the energy aspect. Simulation is there to help us do those things. But one thing you must understand, if you lack your fundamentals in the area of mathematics and physics, it becomes a problem. You must know which equations to consider. You must understand what the result is giving you. What is the physics behind what you are doing? Imagine you don't even know the formula for angular speed or angular rotation, and you are to apply that in a simulation environment. You don't even know, for instance, the yield strength or let's say tensile strength of a particular material. You don't even know how to go about it. If you get a result like a factor of safety, you don't know what it is. You don't know how to interpret it. How then will you be able to come out with a result when you communicate with your fellow engineer who will understand? Okay, so that is very important too. That is why most people say that the calculation we do in class is not beneficial, we do it in the field. But please, those calculations you do it so much important that without it, you cannot proceed with this design aspect you are talking about here. Okay, all right. So the simulation makes things much easier for us, and it's not really about memorizing all the formulas in your head. No, not at all. They are available on the internet. The real strength of this, the formula for this stress, the physics-based model for this particular situation, the fluid analysis. What is the formula? You pick it up, then you put it in the very nice situation, input your parameters, find your results, and compare it, input it into your simulation environment, and see the results. So that makes simulation very powerful, very simple, and interesting.
Okay.
So I'm going to demonstrate that to you using one of the softwares that you all know. But before that, I'm going to show you a calculation, okay, a calculation done by hand, and then we'll compare it to the result you are going to get from the simulation. And then so that we can be able to appreciate how it is. A very simple design, actually. Okay. And so, for instance, let me try and share my screen for us to see. But before that, if there's any question, please draw my attention before I can proceed.
Okay. So whilst you are sharing your screen, I would like to clarify things more here. So
okay,
the existence of simulation is about the speed, because in our world today, we know the demand and then the time related to solve a problem it's actually something that we need to speed it up with the help of technology, as compared to the back in the olden days where a lab is there. I remember when I was in level 100, only to go and do a friction test for friction. We enter a lab and we are many, and see, my materials are not there. The equipment are not there for us to do it at the same time. It's time consuming. It's so boring. You get there and then you have to do it group by group and you have to do tests. But all these things has been they have put everything together in a simulation environment. Just understand it and then just put the parameter and it works the same as being in the lab. So it has it has saved us a lot of cost, and then able to you don't need to ask any permission. Right in front of your computer, you just enter, test your doubts, see how it is. Then you just keep doing it until you get the right thing of it. So I think simulation is the best tool, even though there are even more advanced ones that are even coming to speed up our work. But it's the best tool for us to do a simple test, just a simple test. You don't need to a big cracks. You just take a simple bar with a hammer, just a stress, check a stress and see how benefit it can be. So it's very important as in our era, rather than just going back it is. So simulation is very important in our time so that you can speed up to approach our solutions due to the high demand of the society. Yeah.
Right. That is fine. That's good to go. So
now, let me introduce Mr. Emmanuel.
Okay.
He's the one who was part of us when we were hosting the design engineering. So he's
all right. I think I should know him. Yeah. Welcome, Emmanuel. Okay.
Thank you.
All right. So please, can you see my screen?
Yeah, I can see.
Yeah.
Okay. So now let's look at this situation. Let me see if. Okay. I hope you can see the screen clearly.
Yes, we can see.
Hello?
Yeah, I think so. Prince has already given a thumbs up.
Hello?
Yeah, we can hear you. Can you hear us?
Yeah, you can see.